Ford F-150 pickup trucks. You'll find now graphene components in the engine bay. Wow. So it's reduced the engine noise into the cabin by 17%. It's got thermal properties that have been increased by, I think it was 30%.
Like
and
it's stronger as well.
And it's tougher as well.
Welcome to the Swifty Podcast, inspiring positive change through design, innovation and technology. Hi everybody, welcome to the podcast. Today we're at a different location. We're here at a place called the GEIC. Is that right? I've said it right?
That's correct, yes.
Which is the Graphene Engineering Innovation Centre here in Manchester. We're here today because we're working with these two wonderful people, and we wanted to come in and explain a little bit about what graphene actually is and a little bit about its history. So that's why we're in a different location today. So I've got Lisa and I've got Mark here. We met recently because you're running a new kind of like innovation project to help SMEs like ourselves put graphene into their projects or commercial projects.
Yeah, absolutely. Yeah. Specifically within the Greater Manchester area, we're trying to encourage Greater Manchester companies to adopt new technologies with graphene in.
Yeah, so we, on the lift on the way up here, we discussed just briefly how many projects you've got live at the moment. There's quite a lot. There's 50 or so
about
projects.
50 or so at the minute.
That's ERDF alone, and that's not counting the actual Tier 1 members and Tier 2 members we have as well. So quite a lot going on.
Okay, wow. So there's a lot of stuff happening, and graphene is actually in commercial products already.
Yeah,
it is,
absolutely.
Yeah. And it's a new wonder material that I think we're going to get into this, but I think there's quite a few misconceptions in terms of how it's portrayed as being kind of like the lightest material in the world, but that's not necessarily true, is it?
Sure.
So, I mean, it's amazing to see the growth of it, and we're really excited about putting graphene into that thing over there, which is our new carbon product.
Yeah.
You've actually got a scooter here.
We have, yes. That's been good fun so
far. It's very popular in the office, certainly is.
Whizzing around town.
Yes, it's been up to the Arndale Centre and back a few times.
Oh, right, okay. Yes. Wow, great. Well, one day maybe when we've done what we need to do, and that's put graphene into our scooter, we can
we definitely want some
scooters
here. Yeah,
that's great. To tell the story behind it, which would be great.
Yeah, I mean, that's the really nice thing about working with you guys, is that graphene was invented here in Manchester. Is that correct?
It's
it was isolated here.
Isolated here, okay.
It was always there, but nobody kind of isolated it from a piece of graphite before.
Okay, so I guess before we go too deep into it, do you want to kind of start with explaining to the audience and the people that are listening what graphene actually is?
Yeah,
and tell a little bit of the backstory.
Of course, yeah, no problem. I mean, everybody knows what graphite is. It's basically lots of carbon atoms arranged in a hexagonal structure, and it's in layers all stacked on top of one another. You can see from the models here. And basically graphene is one layer of these carbon atoms, so it still keeps its hexagonal structure, but it's separated from the rest of the carbon material. And when it's isolated like this, that's when it has all its amazing properties.
Wow.
So really high mechanical strength, it's impermeable, it's transparent, it's incredibly conductive, electrically conductive and thermally conductive as well.
It's quite a cool story how it was actually discovered, isn't it?
Yeah, of course. So it was actually a sticky tape method that enabled the isolation of the graphene itself. So it was kind of, people had tried to make it from lumps of graphite, tried to make that smaller, but it was actually by peeling off some layers that they managed to isolate the material.
So was the theory already there before? When they knew about graphite, they thought, if we can try and get down to one molecular layer, is that how you describe it?
Yeah. They assumed it would have very special properties.
Okay.
Probably didn't predict quite how special it would be.
Okay. So that sticky tape method was the first time that they were able to achieve that in the lab. Yeah. Isn't that amazing that you just use... Is it as simple as that? They just use sticky tape?
Yeah. But they used it. They was putting something onto a piece of equipment, and they used to... you need a smooth surface. So they put a sticky tape onto it, took a layer off, and then to clean the surface or something, then they realised what they were getting. So it was exfoliating and separating it. It kept going down and down to end up with graphene. Then they used that to make a transistor.
Right, okay.
Yeah.
That was the first thing they made?
Yes, it was a transistor,
Working transistor.
Wow. What a story that is of
is,
how they
absolutely.
discovered the technique to actually isolate it.
Yeah.
Wow, cool. So what date was that when that was that?
It was
discovered?
2004.
Yeah.
Okay.
And they got the Nobel Prize for it in 2010.
So from not that long ago, we now have this wonderful building,
Yeah,
and also the other building.
Yeah,
the
we have
GI.
two. We've got the National Graphene Institute that opened in 2015, and a lot of the actual graphene research goes on. All of the fundamental work into looking at the different properties of the material.
Yeah.
And then just last year in December
Just before
2018, we opened the Graphene Engineering Innovation Centre.
Okay.
And that's really kind of the industry-led side of it. We work with companies to generate prototypes and do feasibility studies and to try and promote graphene within the.
And that's working with the university, isn't it?
Yeah.
We're still
we are
part
part of the university.
Okay.
Yeah.
Okay. Great. Well, it's really exciting to see the kind of development of the place and kind of how much funding has gone into it. I mean, it's just a huge amount of funding.
It
So the
is.
belief behind this discovery is quite an epic
Oh,
belief. Right?
absolutely! It's a really big thing for Manchester, isn't it?
Yeah.
This building alone was £60 million. Wow. So yeah, it's a
And I've
massive,
seen
massive
all of the
investment.
lovely toys that
Yes,
you
we've got
We
loads of
do.
toys.
We've got a lot of good equipment.
Yes.
So I've had the little tour and it's amazing.
Yeah.
What you have access to.
Yeah.
Incredible. And for us to be able to have access. So we're now, because we're on the program, we can come and like have a meeting here, can't
Of
we?
Yeah,
course,
you can
yeah.
come in,
Facilities.
use the meeting rooms, talk to the
Great.
academics, talk to us guys.
Yeah, it's
Yeah.
cool. I mean, what a wonderful resource for a small company like us to have, your collective experience between yourselves, to then be able to have that as an asset in the company to build and commercialize our products is amazing, really.
Yeah.
So again, thanks for us getting on the project. We're going to be exhibiting soon as well in Manchester on one of your stands.
10th
Oh,
and
at the
11th.
Venture Fest.
That's right, yeah.
Absolutely, yeah.
Yeah,
We've
so,
encouraged a lot of the SMEs that we're working with to come along.
Great.
So we can showcase what we're doing within the city.
Well, we'll meet the other exhibitors then.
Of course, yeah.
Yeah,
Are they all
yeah.
live projects as well?
Yeah,
that you're
the
working
live
with?
projects. Really
Okay.
diverse though. I mean, all kinds of different applications.
Okay.
You're certainly the only scooters that we're working with.
We have lots of composite projects, but that's the only scooter one.
Right, okay.
Yeah.
So are those projects kind of parts that go into another product, or are they?
Yeah, it could be things from lightning strike panels for aircraft to seats for aircraft or railway. We're doing plastics as well for packaging, all sorts of things.
Okay. I before we came here today, we did a little bit of a structure of kind of what we wanted to cover. But one of the things that came up, which was really funny, was Saul was doing a bit of research and he put graphene into Google and looked at what the top 10 questions
Oh,
were.
right, okay, interesting.
And some of them are pretty silly, but some of them are quite interesting. So I was going to just read them off.
Yeah.
And
Okay.
You don't have to answer them,
We can try.
but you can try, and
We'll have a go.
It might be funny. So I'll just read them all off first, and then pick what you want. So, what is graphene being used for? How expensive is graphene? Is graphene stronger than a diamond?
Stronger than a
Stronger
diamond.
than a
It's
diamond.
harder than a diamond, so it's stronger.
Harder, yeah.
Can graphene stop a bullet? Is it bulletproof?
That's in the top 10 questions, really.
Right, okay.
Can I make graphene at home?
A graphene home?
At home.
Can you make it?
Can you make it at home?
Make it at home? Of
Yeah.
course you can.
Yeah.
If you draw with a pencil, you're making
Absolutely.
graphene.
Wow, there
That's
you
true.
go.
If you've got some sellotape and a pencil,
You just
there you go.
draw and then you're making graphene.
Does graphene stab proof? So that English is very bad.
Does graphene
But is it
stab
stab proof, I guess?
Okay.
Does it stop radiation? What is the disadvantages of graphene?
Okay.
Can you break graphene? Is graphene flammable? Is graphene the strongest material on Earth?
In the molecular level, known to man, yes.
So yes, wow.
Yes.
So you can see there's if they're the top 10 questions, there's quite a bit of misinformation there in terms of
Absolutely.
assumptions being made.
Yeah.
And as silly as some of those are, I think it's important to kind of show some of the public perception.
Yeah, definitely.
And
it's interesting about the bulletproof and stuff.
Yeah.
People are always thinking about aramid and Kevlar, and
But we don't,
whether it's
understand what graphene actually is.
No.
That is
yeah, exactly.
treated as an additive.
Yes,
Yeah.
exactly. So that's the main kind of That's a really important point to illustrate, because a lot of people think it's just it's a wonder material.
Yeah, it's not used on its own.
No, they think you get it in a big sheet.
Yeah.
And it's like that. That's not really how it works.
I think some people think it's like a strand of Superman's hair or something.
Yeah.
And then it's you can hang a bus off it or something like that. So in kind of like your own words, I guess it'd be good for you to kind of comment on that and tell us about the additive process and how you actually make a graphene product.
Okay.
So,
do we do what for additives?
Well,
how would you produce graphene?
In our application, there's going to be two ways that we've discussed. One way is as an additive into the resin to make the carbon fibre stronger, and the other way is to an additive into the filament production of the carbon fibre.
Basically the same way.
Yeah,
it's mixed depending on what material we're mixing it into. If it's say an epoxy resin system for your carbon fibre, your pre-pregs, that tends to be done with a paddle mixer to start with, and then it's put through a high shear mixer. Because the problem with graphene, it likes itself.
So that's actually
that
is an example of graphene.
It's graphene powder.
Wow. Okay.
So that's not beautiful monolayer graphene.
Yeah.
That's probably few layer graphene.
Yeah.
Kind of 1 to 10 layers.
Okay. And is that's been produced here?
This is by one of our tier 1 members. We don't actually produce graphene ourselves.
Okay.
We can do, but we don't. We tend to use what's produced by our members.
Yeah, so we work with a lot of companies.
So we're about the supply chain. So there's no point in us making graphene.
Yeah.
Because then we can't supply it to the end user. So we use our.
You want to use an industrial standard product.
Exactly.
To then know what you're doing can be applied.
Yeah.
Okay. Cool.
So that's what we would be adding to a resin system, which then would be made into a pre-preg.
Yeah.
So by, like I said, using that by high shear mixing, it gets added to one part of the resin system, gets sent off to a company where they add the rest of the ingredients to make the resin system up, then gets turned into pre-preg, which is then sent to your guys who manufacture the scooters, who cut it up, lay it up, and cure it, and do whatever they do to finish it off.
Well, hopefully that's what we'll do. That's our plan, is to do that, and then make one in graphene added material, and one without, and then test the comparison between the two.
But with polymers, it is slightly different. So we tend to start off with a pellet. There's different ways we can add graphene to it. We can put it into something called an acoustic mixer, which basically you put your polymer into it, you add the amount of graphene you require, up to 1%. Basically that shakes it really fast and coats all the pellets. And attaches it onto that. But after that, we then have to put it through what's called a twin screw extruder. So that compounds it and basically turns the polymer into molten polymer, and then mixes it and forces the graphene into the polymer itself.
Right. Okay.
And that comes out as a filament. Okay. And then we can produce either more pellets with graphene in, or we can produce blown films, or whatever we want to do, or just a filament for 3D printing.
Okay. The project that you did with Innovate Footwear, so that was a different. That's
different altogether. That was a rubber.
Polyurethane.
Polyurethane. Okay.
So that was done through a process called an internal mixer.
Right.
So that's for more tougher rubbers that are used, like you say, on footwear or for tires or something.
That mixing process, what happens? So we're looking here at a molecular structure, right? Is this what one molecule in diameter or
diameter?
Or thick, you would say? How
thick
would you say
thickness. It's a 2D thickness. Yeah.
So it's one molecule thick.
Yeah, which is why I call it. Say it's a 2D material.
Okay. So when you are mixing, in that case for the rubber, what happens to the molecules of the rubber and the molecules of the graphene? Do they combine together in some way, or what's the resultant kind of structure looking like? Because I can kind of understand this and how this adds those amazing properties, but how are those properties transferred over when you mix it in with a material?
Well, if it's just graphene on its own, it won't be chemically mixed. It'll be physically mixed within. So the mechanical properties come through the stress transfer through the material. It's all down to this surface area,
right? Okay.
And the aspect ratio of the graphene. But you can use functionalized graphenes, which do actually interact with the polymer. Okay. So it depends which graphene you use.
Yeah, I guess it's very complex,
the properties of the material. So it's quite. It's all dependent on the type of graphene you use and the process used to mix it.
Okay.
And then the amount you put in as well also has a.
We don't tend to use single layer graphene. We use what's called GNPs, so graphene nanoplatelets, which is made up of a number of layers. Anywhere between 3 and 5 generally is what we tend to use. It's what the graphene we use is made up of. So the only time you use a single layer would be something from chemical vapor deposition for high-end electronics, so it's actually grown onto a substrate. So like a copper substrate will go through a furnace at around 1,000 degrees C. Methane and a few other chemicals are put into the furnace, that cracks and then attaches itself to the copper substrate.
That's how you get the really pristine.
That's the pristine graphene. Whereas what we use to create a powder is something that's sort of exfoliated. There's different ways of exfoliating it. We can use a 3-roll mill. So basically you put the graphite block through the 3-roll mill. That creates shear. And it's basically separated like a pack of cards. It's like basically graphite's like a pack of cards, and you're just separating those cards into single cards. Or few layer. So 2 or 3 cards stuck together.
Wow. So in the case of the rubber sole for the shoe, that material was mixed together. So the rubber was mixed with graphene.
But that was a different type of graphene altogether as well, because that was a graphene oxide.
So
what does that mean?
That's just a type of functionalized graphene that we use. So it interacts differently, the matrix that it's introduced in.
So like I said, it's not just one type of graphene. There's various types of graphene, and basically there are hundreds of 2D materials. So we don't just deal with graphene here. There's molybdenum disulfide, boron nitride, just to name a couple. So it depends on what people want.
They're all advanced materials or
2D materials.
So 2D means it's
generally one atom thick.
One atom thick.
We can get it to that level.
Wow. Okay.
So depending on what properties you want, depends on what material you use. So if you want something that's thermally insulating, you would use boron nitride. Whereas with graphene, that's conductive. So
depends on your end.
Wow, it kind of every time I come in, like the first time I came here, it blew my mind. It really did, because it was like, it's nano-engineering, isn't it? It's like
basically that's what it is.
A molecule. I mean, it's crazy. It's crazy. Like, we're so used to working at this kind of scale, which is, what would it be? Billions of molecules?
Well, we work at both scales, so you have to
I guess
switch your mind between the two things a lot.
Wow,
imagine trying to coat the hull of a tanker, which has just been done, which is 700 feet long. I think it was 33,000 tons of tanker weight, and they've put the first graphene coating on the hull to test on part of that. So that's out at sea at the moment being tested.
And what are they expecting the result will be?
Basically less downtime.
Super fast.
Durability, so less downtime for the ships themselves. Better corrosion protection. So it's a perfect barrier.
It's almost kind of like unbelievable, isn't it? It's almost in the realms of being magic.
Some people do say it like that, because it's so multifunctional. When we say, well, graphene actually can do that as well, and they say, oh, it's not just one property. It's a bit of a wonder material.
It all depends on how much graphene you add to something as well.
Of course.
So with your product, what you want to do is lighten your product, strengthen your product. So you'd probably use less than 1% by weight of graphene. If you wanted to make your part electrically conductive for, let's say, lightning strike, you'd use a lot more graphene. So, I don't know, maybe 10-15%. Because then you need those layers of graphene to overlap and be continuous.
The way that you explained it last time that I was here, we were talking about how when the resin bonds to the carbon fibre, you imagine carbon fibre as having like peaks and troughs.
It does,
And you said that generally speaking, the normal resin and normal pre-preg that you use, it doesn't fill the trough.
It leaves gaps between the fibres. So with the graphene, it improves the interaction between the fibres and the resin system.
Right.
Fills the voids.
We've seen that under the microscopes.
So then that's where you get your reduction in weight, because you can use less material.
Improvement in mechanical properties, which allows you to reduce the number of plies, which obviously reduces your weight.
Wow. So there's the myth of, is it a very lightweight material? It's actually, you just use less material to make the resultant part lighter. Wow, it's so cool. You must love coming to work, right?
It's different every day.
Working on such a variety of projects.
We work on so many different things. It's never a dull day.
And you're seeing like real implication, real what's the word? Real impact, right?
It's incredibly satisfying seeing something that's got graphene in that we've worked on.
Yeah,
It's very good.
and see, I mean, the closest to home example is the Innovate shoe that I've seen, and seeing it go commercial,
Sure.
and be out there on the market that you can buy. It's like, wow, look, it's happening.
But you can also buy a car which is made with graphene-enhanced carbon fibre panels.
Who's doing that then?
BAC Mono in Liverpool.
Oh, right, wow.
So he's made 35 cars, I think he's made
Yeah.
and sold. So that's all made with graphene-enhanced tooling
Okay.
to make the graphene-enhanced carbon fibre panels. So a single-seater road car.
Yeah.
Wow. So you
Very
can make it
nice.
even lighter.
So he's made it, I think, between 15 and 20% lighter.
Took 25 kilos off the car by putting graphene.
But it was only 600 kilos to start
Yeah.
with.
And what's the size of the engine that goes in one of
It's
those?
2.5 litre.
Oh gosh.
So,
It was fast.
And what's the whole weight? It's probably like a couple of 100 kilos.
600 kilos the whole
600
weight
the whole
of the
weight.
car, of the old one, but what the new one is.
yeah.
think-
They've been exhibiting it recently
Yeah.
around the country.
Right.
I
Okay.
think we've got it here in a few weeks, actually, in December.
Yeah,
They're gonna
we have.
be
It
bringing
will be at
in.
the NGI actually.
Oh, it's at
At
the
the end,
NGI.
not on this site. Yeah.
Yeah.
Okay. Cool. Wow. So what other projects can you talk about that you could tell us that's really
One-
exciting or
I
interesting?
suppose ones that are happening in here we can't really talk about. But one that is out in the open in public domain is the Ford project, I suppose.
Absolutely.
Okay.
Which Ford are now using a graphene-enhanced polyurethane foam in their engine compartment.
Ah.
They came across it by mistake, did some research, and they're in all their Ford F-150 pickup trucks.
Oh,
You'll
right.
find now graphene components in the engine bay. So it's reduced the engine noise into the cabin by 17%. It's got thermal properties have been increased by, I think it was 30%.
Something like
And
that.
it's other-
And it's stronger as
and
well.
it's tougher as well. So what we're able to do is actually, because of the thermal properties, they've been able to get the PU foam parts closer to the engine itself and
right.
exhaust. Because it's
right. So there's
the heat. And so the packaging is reduced by quite a lot.
Yeah.
Wow. How does the thermal qualities work? How does that
It gets
work?
rid of the heat, it disperses the heat
Yeah.
Okay.
out of the material.
Okay, because it can travel through
Yeah.
quicker.
Yeah. It conducts heat.
Yeah. That's what
Right,
it's supposed
okay.
to do.
Wow.
So that's one of the big ones that's out there at the moment.
And how about sound? How does that work with sound? How does it produce a sound barrier? Did you say?
Physically,
It-
yeah.
it's
physically?
Yeah,
because
it's-
it makes the foam denser,
Okay.
so that reduces the amount of noise that can get through it into the cabin as well.
Okay.
Because these foam parts actually wrap around other components.
It's just hard to get your head around.
Of course it is.
If
It's
you
so
think
hard
this
to
is
get
this
your
is
head
what you
around.
see,
Yeah.
what we're mixing.
You're mixing
Yeah,
that's what
powder
you would see.
with a different powder or a different
As I say,
polymer melt.
it's just that kind of whole magic element come back.
Black magic.
Yeah, it really does.
Yeah.
It really does. It's like, are you all taking us for a ride? You actually telling us the truth. No, I obviously do believe it's cool, but it's
But when you start to see the data,
sure.
Yeah, I mean, in Mark's lab, when you do mechanical testing
Yeah.
on polymers that have got graphene, you see a huge difference.
yeah, I can't wait to see that.
We can do in that.
Yeah,
I can't
definitely.
wait to see
Yeah.
what the data shows from the strength tests and the BSEN tests that we'll do on it. And
We're hoping it'll be pretty dramatic. I mean, based on what we
Hopefully.
know from the automotive projects that we've been working on, it should work really well.
Well, even with coatings, if you do
Yeah,
your
coatings,
aluminium frames that you do for people who use the yachts, like the sea, that
Oh,
one we've got
right.
here,
Yep.
you put the coating that Lisa's working on that, then that seals it, protects it from.
Protective.
really, just the coating on the
Yeah,
outside.
Yeah, that's what. Yeah, it's a perfect barrier.
Wow.
That's why this ship has been coated with it.
So what's the process of how you apply the coating to
Well, again, the graphene's sort of like an additive. So
Yeah.
you design your coating formulation, and then you pick which type of graphene. You obviously have to do some experiments to
Yeah.
figure out the best
Yeah.
graphene for the coating in terms of compatibility with the chemistry and application of the coating onto your product, and then you will literally just use it as a normal coating. As
So
you
you
would
could
anything.
you could literally
It's like
paint it on.
paint.
Wow.
Yeah, I mean, paint.
Spray-
is quite-
spray
yeah, or
paint-
you could
spray
spray
paint
paint
it on,
or you
yeah.
could, yeah, absolutely.
Wow. So many things you could go into, right? Wow. So when it was very first kind of discovered, do you know anything about kind of the journey to like how they managed to get so much backing and kind of so the way I'm explaining it is like the way I'm imagining it is because we've like created a company out of an idea, and I guess those guys, they've made this discovery, which is really interesting, and then you now see so many millions of pounds that have been spent into this and real impact being driven, and it's going to revolutionize the industry, right?
Yeah.
As a molecular engineering, let's say. Was there any other businesses at that time doing something similar? So like from kind of like a molecular basis, actually
Not that we're aware
creating
of.
new products.
I
And
think so. I think no,
Not with 2D materials.
Not 2D materials. No, I think that was the first one.
Yeah.
Which is why I suppose they got the Nobel Prize.
yeah,
People
okay.
assumed that 2D materials like graphene wouldn't be stable on its own. So there wasn't
That
a
was the
huge
conception.
amount of effort to try
Okay.
and make them because they assumed.
So who was it that had the vision of going, wow, this is amazing, we can actually change the world with this? What was there someone that had that vision and then applied for the funding and kind of
it's different people from different industries will pick out, because it's multifunctional. It's not just one property. It's got mechanical properties, it's got electrical properties, thermal properties. So somebody from probably each of those types of industries, or whether those properties would be used, would say that would be good.
Yeah,
we could
I
put
guess
that into this,
once
or
the paper was published as well, and people realised
understand it a bit.
the properties that it had, it just
The
escalated
impact.
from there.
Yeah, it's
I
just,
suppose you think the transistor was the first thing to be made, so that industry would be the first ones to think, what can
was
we do
that
with
commercialised? Was that then?
I couldn't tell you off the top of my head, I don't know.
Okay, it's just really interesting to see, like, you know, in the short amount of time that it was discovered, this whole industry has been built, and so much funding has gone into it, and it's obviously having a big impact. It's great.
hitting lots of industries.
It is,
I
absolutely.
mean, it's even
things you've never even thought about.
no, you can go from printing into clothes, smartwear for clothing, like say stab-proof vests.
Wow.
It's going into also get into medical applications, even for drug delivery systems.
Wow.
Because they can functionalise the graphene to target different things.
Really?
Yeah. There's a lot of work going on in Manchester around the drug delivery systems and all sorts of treatments for dementia. There's all sorts of things.
Really?
For that.
And as you said, the smart textiles one is a big one. Lots of people are interested in the smart textiles.
Even from things like pairs of gloves for people who have problems with circulation.
Okay.
Yeah.
So what would that be, like thermal?
So you can heat the gloves up, so you don't have to carry around a big clumpy battery. But you can,
the whole thing would be conductive.
So the actual fibres that are used to make the glove, you can weave into the glove itself, which we make downstairs.
Yeah, we're making graphene fibres downstairs.
So,
Gosh, it's amazing.
it's getting more and more known now. People actually getting to know it and trust it a bit more because more and more information is coming out.
Yeah, okay.
That was
that's
the
key bit,
biggest part of it was getting information out, which is proving what it can do.
Yeah,
And because it's a nanomaterial, people hear nanomaterials and they obviously have concerns.
Yeah, I guess
so we have to address that as we go.
Okay.
Of course.
So the concerns are that it's so small and minute.
Yeah,
how do we
hazardous.
control
It's
it?
just
Exactly.
handling it. How do you
Handling
add
it.
it into your products?
Okay. Is it a hazardous material to handle, like in the open?
We are doing toxicity tests at the moment. That's being done. There's a lot of people looking at that at the moment. So
How it should be controlled and
Certainly for inhalation, you wouldn't particularly want to
breathe it in.
inhale
or anything that's tiny.
nanomaterials.
You wouldn't
exactly.
want to, right?
No,
It
not
goes
at all.
without
But I
saying.
mean, we do everything very safely here, so it's all in a controlled environment.
Yeah. Okay. Wow. So how many people are here working with you in your department?
With 30 now, I think, in the
In the
team.
GEIC, 30, maybe 35,
35 people.
Wow.
But within the whole university, it's
Over 300.
well over 300 people.
Really?
Working on
doing
graphene alone.
Wow.
Yeah.
And how is all of that funded? How are all those projects funded? It's from European money, so
Some of it's from
Some of it's
European,
European. A lot of it is just industrial collaborations.
Okay.
So as Mark kind of alluded to before, we have membership schemes here. So
Yeah.
companies can come in, they will pay a membership fee, they'll get a lab here, they get to work with us, and then they pay for different projects. So we work together. So it's lots of
That's
different
really
ways.
cool. And companies from all around the world have been coming
Oh,
to
yeah,
Manchester.
absolutely.
We've got members from
Right.
Australia. As far away as Australia.
Yeah, we do.
So, yeah.
And we're like literally
You're
about
down the
2
road.
miles
Yeah,
away.
you are. Yes.
That's okay.
So we're
It's
very
easier
lucky.
to get hold of you though. So
Yeah.
We can walk to your place.
That's why I was early today. I was like, we set off half an hour early and we got here literally in 10 minutes.
Yeah.
Come on a scooter.
Yeah, well, we should have done. But
It's not really-
as you can
it's
see, it's
Manchester,
wet.
it rains. It's,
I know. I mean, we do scoot in the rain, but it is miserable. It's miserable.
Yeah.
So we came in the van today. But so, well, we're really looking forward to getting
can't
properly into the project
No,
with
we
you,
are
which
too.
is going to
Yeah,
start,
definitely.
I guess, pretty soon-ish. Really thank you for giving us some time today and explaining.
No problem.
I think if you want to learn more about graphene, then we're going to put the links on the podcast. And if you're listening, go onto the journal page of our website, and you can see a write-up of this podcast on there, and there'll be links on there as well. So, thanks for your time today, guys.
All right.
It's
No
awesome.
problem.
Keep up the good work.
Yeah.
You're changing the world.
We're trying.
And thanks again.
Thank
Great.
you.
Thanks for listening today, and we'll see you next time. Cheers.